Alright, so hello. Today we're going to be giving a short introduction into randomized block experiments. This is going to be kind of a short conceptual introduction to how we're going to separate our experiments, how we can conduct them in more accurate ways. When we're dealing with new materials and machinery, testing is a really vital role in understanding how to approach the production of our systems. These experiments are useful for any discipline of engineering, from mechanical to aerospace to industrial. When we're making our randomized experiments, there are typically two different ways to categorize it. There's blocked and then there's non-blocked. Today we're going to be going over blocked experiments and then the pros and cons of blocking. So to begin with, let's imagine that we're making a cell phone tower and we need steel cables to provide tension to the tower so it doesn't, tip over. So let's assume that we have 30 steel cables that we're going to be using for this random cell phone tower that we're making. Since we know that different temperatures of, we live in Florida, we have a bunch of different temperatures. Let's imagine that we have 30-degree weather, 70-degree weather, and 110-degree weather. So since we know that tensile strength of the steel cable that we're using is going to fluctuate depending on what the temperature is, we're going to have to run 3 separate tests. So we have our 30 steel cables. We're going to do 10 tests in 110-degree weather, 10 tests in 70-degree weather, and then 10 tests in 30-degree weather. All 30 of these steel cables are going to be about the same. They're going to be pretty much identical in length. They're going to be unused. All the dimensions are going to be the same. And we're going to use those tests to kind of give us a good indication of whether or not the steel cable will be suitable for this project. Now, this is just your typical randomized experiment. Like I said, we're going to assume that most of these cables are the same. There is one issue with it, a potential issue with it, and that would be our manufacturers. So we're going to go over to the blocked experiment, and let's assume that now that we have 2 different manufacturers. So you have manufacturer A and manufacturer B. Although most of these steel cables are going to be the same, and we can assume that we're going to be the same, for a construction project as big as this, we're going to have to test our manufacturers and make sure that we don't have any kind of discrepancies in that. So as you can see, we're running the same tests. We're doing the 110-degree weather, 70-degree weather, and 30-degree weather. But this time we're going to split up manufacturers A and B to begin with, and then I'll give us 2 different results. And let's say for the sake of this experiment that manufacturer B doesn't hold up in 110-degree weather. We wouldn't have been able to find that out in our non-blocked experiment. So that kind of gives us an advantage when we use randomized blocking. And a lot of these factors, whether it be weather or manufacturer or stuff like that, these are considered nuisance factors. These are things that you don't typically test, but you can block to factor out. So that's kind of a general overview of randomized blocking and kind of how it can be beneficial in this field.